Whoa, that is not in the right spot. That is nowhere close to where I put it at. Hey there, Mission Control. Okay, well, first of all, congratulations to NASA and JPL for landing another probe on Mars. Very excited to see how that's all going to turn out. It's really cold in here, so sorry for the heater. Hopefully the mic does a pretty good job. Start my book here. The very first thing we did was put the stepper motor controllers on. So these are little black things like this. They're really easy to do. There is color coding instruction. I'm just leaving it hanging right now because the instructions on where to put these at are not clear. So I'm going to get all of them assembled and then I'll give you a close-up. There's a close-up of the wiring right there. All right, the next thing I did is ran each of the primary wires from the stepper motor controllers to the overhead controller here to take the small power supply, which is only used to power this, and connect it in. Here's the next setup. You actually need to run power, which they didn't send me a wire, or cable I should say, so I had some left over and I used it, but 2 conductor wire coming off of each of the motor controllers, and you run them all up to the main power supply unit. Got a piece of MDF there, just going through and we're dialing everything in, doing some basic cuts. I got to buy the Mach 3 license. It's $175 and I'm considering going to Mach 4, but I need to do some testing first. It has been 6 days since I started putting this thing together. The frame went together really well. Really no problem there. That took just a few hours. But then all the electronics, the motor, everything, it took days because the instructions were horrendous. Basically, they weren't there. There was no instructions. I had to figure out the wiring scheme, do some soldering here. I had to figure out where to mount things at, how to run the cables, all of this stuff. No instructions for. But it's a kit. I don't, you know, you get what you pay for. And obviously the 3D printer that we bought was way more expensive than this, and it came with amazing directions. But this was a kit, you know, it came with what you'd expect. It's been really cold, so I got the heater out here because my hands are just turning purple. It's actually nice outside, but we got a breeze going and it's just really cold in here. So sorry about the noise there. Using Mach 3. Oh, hold on. Yeah, go ahead. We got Mach 3 going on an old laptop, and Mach 3 is one of the more common, I think it's actually the most popular CNC CAM computer-aided machining software that you can get. You can get it free to download, and it has a cap on it. You get 500 lines of G-code, which for a lot of things is going to be just fine for the hobbyist, but for what we're doing, we need a little bit more. So I got it installed, and then it took a lot to get the spindle, which is on a variable frequency drive, to get it talking with each other, get all the wiring right, because there's no instructions there. Finally figured it out, and then praise God we didn't have it burn out, and I think he's been answering a lot of my prayers on this project. Then you have to go in and you have to configure everything in Mach 3, and I really want to do a series of videos on this table as I get it all figured out, because like where to put the stops, how to mount everything. There's really not a lot of information out there for the Queenbee. The Workbee, which is a smaller version of this, the older version I should say, there's lots of instructions for, but they're not the same. They're very different. So I do want to do some videos, but I've got to get this tower built. So right now what I need to get onto is actually, I need to bring in some of the design elements. I need to put them on the sacrifice board here, the test board, and we need to do some more testing, do some measuring, make sure everything is calibrated, and then the plastics have shown up, so we could actually start putting plastics on and start assembling the table, or I'm sorry, the grow tower, which is very exciting. But first we do need to do quite a bit of testing here. So I'm going to be spending today doing some testing, and I think I might be able to get you some cool shots. For those that aren't very familiar with computer-aided design, CAD, or computer-aided machining, CAM. You know, when I went to school, I learned about CAD, but CAM is kind of a self-taught thing. Solidworks is the program that I use to do both CAD and CAM. Those are two different disciplines. The CAD is the design, right? Like this simple TRM thing that you just saw get cut. You come in, you make your part, and there's tons of videos out there on SolidWorks, and there's free classes. And if you're a veteran or a student, you can get SolidWorks for free or a very discounted price. By very discounted, we mean tens of thousands of dollars. At Eden, we have to pay for it because we're using it for commercial purposes. So we are on the full version of SolidWorks here. But basically, you come in and you create your design, and then you actually have to set up a machine. And I'm not going to go through all this. I just want to give you the general idea. You set up a machine. You tell it what type of stock you're cutting. In this case, we're cutting on MDF plywood. You set up a coordinate system, which establishes which way is left, which way is right, which way is up and down. And then you go through and you tell it how you want to cut and what pieces you want to cut. In this case, I told it I want to cut out the M, then the R, then the T, and then cut around to do all that. So what I need to do now is actually, I'm on the network here. My network gets a little, oh, there it is. All right, so I can go to my actual network drive here, and I can get on to my CAD, which has my actual grow towers. Where that grow tower, version 2.1. And what I'm going to be doing is I'm going to be opening up the grow tower, which is stored on my computer up at the house, and then it's beaming over the network here. It's going to be a little slow because it's doing all that, and these are big files. But it's going to be coming, and we're actually going to open up and start pulling pieces off of that design, and we'll cut them in MDF. And then I actually have some old HDPE, high density polyethylene 1-inch sticks that we'll play with, and we'll see how well it does. MDF, plywood, and HDPE based on, I downloaded an app here. It's actually way cool. What is it called? What's the name? What's the name of you? The Feed Speed Wizard, which is a great thing to get on Android. You can also use it on your iPhone or on your computer. They have a website, but it's a little app. And this is kind of the most complicated piece so far for me. I'm sure many CAM folks that are out there that know CNC way better than I do, will tell you there's way more to it than this. But for just getting started, this little FS Wizard has been great to establish my feeds and speeds, which I then enter into SolidWorks. And essentially, I create a library. So for all the bits, the different types of bits that I have, which are very, very basic right now, I'm not doing anything fancy. But I bought these really cheap bits on Amazon. The reason I did that is because, when I did the plasma table, there's lots of learning to do. I mean, a lot of learning. So I knew I was going to sacrifice some bits, so I bought the cheap ones. I don't think it's smart to go buy the most expensive bits when you're just learning how to do CNC. So I got these bits, got the calipers out here, measured the information, type it into FS Wizard, then type that into SolidWorks, and SolidWorks does all the calculations based on that. And then you just got to verify everything out there on the table. That's why we're going to be doing a lot of testing. So as this thing loads, 283 of 926 components, you can see it's going to take a while. We're going to pull some of the features off the tower, and then I'm going to put them on that MDF and actually do some cuts, because some of the cuts that we have to do are about, they're anywhere from a millimeter, which is about a 1/16 of an inch, a little less than a 1/16 of an inch, and then down to a 1/4 of an inch, which is what, like 2 centimeters, something like that. So we're going to be going different cuts, and we have to do some ledges and stuff for some of the things that click in, the power adapters and such like that, which is a key reason we needed this machine to do that. And once we get it set, once I kind of get it all figured out, then I can do a lot of them, which is going to be great. Oh, before I forget, so you saw the table. If you're a CNC person, you know this already, but I really need to put my actual, I'm going to go through and drill. I still need to level it, and I still need to drill all the holes to actually put in, what are those called? T-bolts, which are the little 1/4" T-bolts, which suck up into it, and then you can actually put clamps on the table. That way you can clamp your workpiece in. What I've done out there right now is I've just screwed them into the MDF. I anticipate I'll probably need to buy another MDF board, which is about $48 locally from the local lumber store to make that piece out there. And I still have some left over, so I know I still need to do that. There's so much to do and so little time to do it. But so I still got to do that. We're going to get these components here off of this design. Then we're going to go cut them out there on the table, and then we'll actually switch over to high density polyethylene. We'll see how this bit performs on that. And then we are going to have to do some different calibrations with these different size bits, because we do actually need to go smaller in order to make the full design. So a lot to do. 6 days. It's been 6 days. Yesterday I took off. We started recognizing the Sabbath, the day that the Lord rested. So on the 7th day he rested, and that is actually Saturday. So we started doing that, and so it's actually really nice. You take the day off, you do nothing, do whatever. You hang out with my wife. We do a lot of Bible study. It's been great, and that was yesterday. But now I'm all sorts of tired. I want to take the day off today too, but we got to get this done. While I'm waiting, this is a nice little addition to the shop here. I got this little Mueller, I think it's Mueller water boiler. And then I like this Good Earth sweet and spicy tea. It's caffeine free, but during these cold days, you know, it's nice having something warm on your hands. I can put gloves on, but I don't have the same tactile sensation with gloves. You know, I got some gloves here. So I like to get some nice hot water in here. Not too hot, because then you can't drink it. And steep this tea, and it just really makes things a little more enjoyable out here while it's cold outside. Let that do its thing. What do you guys do to help stay warm out in your shop? I got the heater going. Got the other heater going out there. Wood stove would be nice, but what are the tricks? Well, whiskey is always good, but you know, alcohol's not agreeing with me as well as it used to. I guess getting older. Okay, well this finally opened up. Well, no, it's still working. It tricked me. But here we have the tall tower, and one of the things we have to cut is actually on the side here. It's kind of hard to see probably, but we'll actually be cutting the name of the company, Eden, into the side. And then on the back here is actually the really hard one that we have to do, which is it's a flat panel that has a double level of cutting that needs to be done. It has a all the way through cut. Let's see if we can get it here. So here's the piece right here. It actually is pretty complicated. We're going to probably have to do a tool change on it. A tool change is when we change out the bit. What we have is this flat piece, and then there are cutouts and holes which go all the way through. And then in these particular sections right here, there's actually a step where it goes down, then it comes out and goes down again. And the reason for that is because there's actually recessed power outlets that go in there, and they need a particular depth in order to click in. So we're going to do some testing here. And these little guys, what? They're 0.01 inch, so less than a 1/16 of an inch. So we got to use, switch over to standard, there we go. Yeah, boy, that's that bit right there that we got to use, really, really small bit. And that's just so we can put the name of the particular thing that plugs in there. That way people always plug stuff in the right place. So we're going to take a piece of this, and we're actually going to set it up in CAM. So I'm going to recreate a piece here. This is it. Pretty simple work that we have to do here. We need to come over and get those dimensions on that thing. What is this? This is 1.18 by 1.18. All right, so now what we've just done is we've recreated the little piece, just a little piece of this right here. So we just this cutout, and we're going to do some testing with that in CAM. The table is set up on metric right now, and it's all dialed in. The table is on metric. It's all dialed in. That's its default, and I do not want to go through the battle of changing the systems right now. So I'm just going to change. It's really easy in SolidWorks to go back and forth. So we'll just deal with it there. So what I just did is just set everything to metric, and now I need to go in and define my machine, which I already have set up, which is great. So I just hit select. The stock, we're just going to leave it. It is on plywood right now, which I typed in. And what we're going to do is just create a little bit. Actually, we don't need to do that. You can extend how much material is around where you're cutting, but that's not that important. Coordinate system is uber important. It needs to be at the top of this whole thing, and then you say which way the X is going, which way the Y is going, and the Z. Now we got the coordinate system made, and now we're going to add a mill. We tell it what plane is the top. Boom. And now we're going to add a feature. You know what? I think I could actually do this. Extract machinable features. There we go. There's one. There's two. All right, so that did it for me. Generate op plan. Generate tool path. Make sure it chooses the right bits here. Changing tools is really easy in here. You're seeing me learn live here. Okay, so now what just happened is we have all the proper stuff is done. And you can see the path and everything. What we'll do is we'll generate the path. We'll simulate it. There it comes in. Now, since I already typed all the parameters in for this particular bit, it knows everything. All I had to do was set up the new part, and I didn't have to go through the hour-long learning process of figuring out all the speeds and everything. So as you add new materials, you can build up your library. You can actually pay for libraries or download libraries that are out there. SolidWorks comes with an extensive library of CNC information. However, in this case, what I found is it was better for me to kind of start on my own for learning, certainly. So here we go. Look at that. It's just cutting right through everything. Little bits at a time. I've noticed with this particular bit, which is about an 1/8 inch bit, that it leaves a little fuzz behind on the MDF. I slowed it down, I sped it up, and it really doesn't make any difference. It's just kind of is what it is. So it looks pretty good to me. So we'll send it to the post processor now. This is a test, and we gotta hope there's less. Oh, there's over 700 lines. Oh, okay. So I need to pay for the program. I haven't yet. So oh man. So I ended up having to buy the Mach 3 license, the Mach 4 setup. I downloaded it, I played with it a little bit, and it would require me resetting up. Oh. Out of fuel in the heater. I'll have to fix that. I downloaded Mach 4, which is the newest version of Mach 3, because 4 comes after 3. And I played with it. My hope was that I'd be able to quickly bring over the settings and everything. And after about 5-10 minutes of looking at it and playing, couldn't get it to work. I refused to go back through the last 6 days. So I bought the Mach 3 license, which isn't too bad. And now we should be able to do everything we need, because you can have like over 10 million lines of G code, which we should never even get close to. So I just home the machine, and we're going to load the file here. So when you do these tests, when you do everything, you have to home the machine, and then you have to home where your workpiece is at. And by home, it means set the 0 coordinate. You know, where is home? Where's your starting point? There's so many more calibrations I probably need to do here. We are at the good enough point. But now what you do to set home, you just simply go through and say, that's where my workpiece is at. Click, click, click. Made this little table here, so I have my laptop out here. And rise it up. Get it out of the way, make sure nothing's going to clear, and hit start. So now some CNC machines, this one could probably even go faster, but I went through when I was doing the calibration, I tried to go really fast, and it just wasn't having it, so I actually brought it down to where everything seemed right, it seemed to be moving, and we calibrated it, and it's holding its calibration well. So there's certain speeds that you're going to get when you pay for a less expensive machine, and there's faster speed you're going to get with the more expensive ones, of course. Here we go. Spindles on. Oh, glasses. Sorry. Safety Sally in the house. So on Mach 3, it shows me the G code over here that it's going through, its coordinates, and I actually have a view of the table here, which I believe I can zoom in on a little bit. There we go. And we can actually see the piece that it's going to go through. So now it's coming down, it's telling me it's coming, whoa, that is not in the right spot. That is nowhere close to where I put it at. Oh, so these are problems that I had before. Honestly, I don't know what caused them, but there's this offset. It should be over here in the middle, and it's offset, which before was a calibration problem, but I calibrated it all, so I don't know what's going on. Who knows? So I'll get this figured out, get it dialed in, and I'll come back and tell you guys. All right, well, I think I figured out the problem. It had to do, in SolidWorks, there was a setting that I didn't click correctly, so the axes, the X and Y axes were actually flipped, which is why it went out to the middle of the wrong part. So if we got it right this time, we should actually see it go somewhere right in here. It's cold out here. There we go, and stop. Boom. So now I'm going to keep my finger on the stop button here. There we go. You can see that MDF flaking like that. I'm going to need to look that up. If you guys know what that is, let me know. I can do it different. We're doing it, baby, doing it. We're making it happen. Oh, that's looking great. All right, here we go. Now we're going into the middle. Now remember, the stock that this would be cutting into is actually 1/4 inch thick HDPE, not wood. It's MDF. I got this old piece of HDPE that I had. It's a little bowed on here. I should probably put the thing in, but for testing it's okay. Did some quick measurements with it. It's secured in place onto the board. Spindle's going. Got the axis right, at least I think I got it right. And here we go. Finger on stop. This is pretty soft material, but we're going to be watching to see if we get any hang-ups here. A little cold as well. About to where it's going to begin. And here we go. Really not bad at all. I think it's hard to see it because it's white. Looks like we're offset a little bit. That's why we do testing. That's chewing through it really well though. I had no problem with that. But we're doing it. We're cutting. I've got a lot of testing to do. It's Sunday, so I wanted to get here. I need to get everything calibrated for tomorrow, get the work week going, and actually we're going to be cutting plastic. So the tests so far today have been great. A little more alignment issue here, and we're going to have this thing dialed in. Really, really excited for the capabilities that this machine brings to the Eating team here. And yeah, I hope you enjoyed this video. If you did, be sure to give it a thumbs up, hit subscribe. Don't forget to ring the bell so you get notified when I put up new videos. And if you really like what we're doing, you can help us out on Patreon. You can also join us on Twitter and Facebook. In the meantime, this is The Real Martian, out.